Solving inequalities. An important note. When graphing and writing interval notation, when you see an example where the variable is on the right-hand side, it is easier to interpret the graph or the interval by switching everything around. So when the variable is on the right-hand side, you can switch it by turning everything around. So sometimes what I like to do is take it on a written piece of paper and flip the paper upside down, and it shows me the way that it should be written properly, where the x is on the left-hand side and my inequality is pointing in the right direction. So you don't want to change what the inequality is stating. All you want to do is rewrite it so that the variable is on the left-hand side. So when you do this, you have your written inequality where your variable is on the left-hand side, but it still means the same thing as you started with. So when you have the variable on the right-hand side, either you're going to, when you're talking about graphing, you're going to shade in the opposite direction of the way that the inequality is pointing, or you can switch everything around so the variable's on the left-hand side and the inequality will point in the direction of your shading. So in this case, if I were to graph this inequality, this would be my solution. To graph it, because it's a less than or equal to, it has the line underneath it, we would use a bracket to graph it, and we would shade to the left because it's every number -2 and below. So that indicates that we're going off into a negative infinity. So when I write my interval notation, you're going to start with what is at the first position, which would be that negative infinity, and it's going all the way up to -2, and you use a bracket at -2 to indicate that it includes, or it's also equal to. But remember, infinity or negative infinity never gets a bracket because it doesn't end, so you can't close it in with a bracket. So always make sure with infinities you use parentheses for your interval notation. So when we're talking about solving inequalities, it follows the same steps as solving an equation. So when we are solving an inequality, we're going to use the stepping process for equations. Now there's one rule that you have to know, and the rule is this. When you're solving, if you, at the very last step, if you multiply or divide by a negative number, you're going to need to flip the inequality symbol. So you're doing the multi-step inequality, you're following the steps of equations to solve, and you get to the last step. If your last step you multiply or divide by a negative number, you're going to have to flip the inequality symbol. I want to show you what this might look like. So you did a multi-step equation, you're down to one step to solve, and this last step you have to divide because the number's attached to the variable, that's multiplication. The inverse operation would be division, and because what's attached is a -5, you have to divide by a -5. And because you're dividing by a negative, that's where this rule is going to come in play. You have to flip the inequality symbol for your solution. So when you're divided by a negative, you have to flip the inequality symbol. Now be careful, because you might see a scenario like this where I have to divide to solve here. I have to divide by 5, that's what's attached. So when I divide, I'm dividing by a +5. So it doesn't matter that what's on the other side of the inequality is a -10. I'm dividing by a +5. So when I get my solution here, I'm going to leave the inequality in the same direction because I'm dividing by a positive. So my solution would be x is less than or equal to a -2. So you only flip when you're dividing or multiplying by a negative number. So if we have a two-step inequality, the order in which you'll solve the two-step inequality is the first step is you will undo the addition or subtraction, and then the second step you undo the multiplication and division, similar to equations. So when you have a two-step inequality, something similar to this, the first thing you're going to do is get rid of the plus or minus, and because it's plus 5, we're going to subtract 5, and then you'll deal with what's attached. Now you always want to think in terms of this rule. When you have your last step, if you divide by a negative, you're going to have to flip the inequality. So I have to divide here in order to get x by itself, but I'm dividing by a positive, so the inequality will stay in the same direction. Now I can graph this and write my interval notation. Your solution will be written in interval notation. So the graph here would have a bracket at 7, and you're shading to the left because it's less than, and your interval notation will be from a negative infinity to 7, and it uses a bracket to indicate that it also includes 7. So this next example is a two-step inequality. You have to be careful here because the first step is you want to get rid of that positive 26. To get rid of that positive 26, you have to subtract. So you subtract from both sides. What's left now is a negative 3x. So be careful when you bring down that 3x that you bring down that minus sign with it. And now it's a negative 3x is greater than or equal to 6. And you have to divide. And because we're dividing here, that rule is going to come in play. We're dividing by a negative, so that rule is going to come into play. And that means that you're going to have to flip the inequality symbol. So your answer would be x is less than or equal to a negative 2. So it's very important that you remember that rule on the last step. And then you would graph the solution, and again, because it's less than or equal to, it's going to be a bracket, and it's getting shaded to the left, and then I write the interval notation. It's going from a negative infinity to negative 2, and including negative 2, so I use the bracket. Pause and try. So in this case, I subtract 11. I'm left with 3x is less than or equal to a negative 6. And then I have to divide through by a negative, which is going to flip that inequality symbol, and I'm left with x is greater than 2. Now I'm going to graph this, and I'm going to write my interval notation. So it's going to be a parentheses at 2 because there's no equal to symbol, and you shade to the right. And then my interval notation will start at 2 and go off to positive infinity. Pause and try. This is still a two-step inequality. Your first step, get rid of that 5, minus 5 from both sides. And then you're going to be left with this x over 2 is greater than a negative 14. Now remember, when you have x over 2, that line means that that's division. 2 is being divided into x. So the inverse operation here would be multiplication. So don't let these type of problems throw you off. They're still two-step inequalities. So I end up with x is greater than a negative 28. I'm going to have an open parentheses at negative 28, and I'm going to be shading to the right. And then the interval notation will be a parentheses negative 28 going off to positive infinity. Make sure you use parentheses on the end, not a bracket. Pause and try. This is a two-step equation. I'm going to isolate the variable by first doing the addition or subtraction. And remember, whenever there's a fraction attached to the variable, you want to get a coefficient of 1, which means you're going to have to multiply by the reciprocal. So the reciprocal would be 4 over 3. Whatever you do to one side, you do to the other. Now you have a whole number multiplied by a fraction. Put that whole number over 1 and then simplify first and multiply across. So your final solution here would be x is less than or equal to 20. And now you can graph it and write your interval notation. So your graph is going to have a bracket because it's less than or equal to, and you're shading to the left, and your interval notation here would be a negative infinity to 20 with a bracket. So as a reminder, for multi-step inequalities, it uses the same thing as multi-step equations. You always want to do the distributive property first. If there's parentheses, you want to remove the parentheses by distributing the value that's on the outside to everything inside the parentheses. Then you'll combine like terms. Now like terms will be on the same side of the inequality symbol. And to combine like terms, you're going to add or subtract the coefficients. Then you'll get the variables to the same side of the inequality. Now, if you have variables on opposite sides of the inequality, you're going to have to move to get them together. And whenever you move from one side to the other, you will have to do the opposite to get them together. And then you'll have a two-step inequality. You'll undo the addition or subtraction, and then you'll deal with what's attached, that multiplication or division. And always think at this last step of that rule. If you multiply or divide by a negative, you'll have to flip the inequality symbol for your solution. So we have a multi-step inequality. The first step here is we're going to have to do the distributive property. So you're going to do the distributive property. Always double check your arithmetic that you multiplied all the way through. So you have that 3x plus 15, because 3 times 5 is 15, and then we're bringing down the plus 3 is greater than 51. Then we're going to have to combine like terms, and the like terms here is that plus 15 plus 3, so we get plus 18. Now it's a two-step inequality, so we're going to subtract 18 from both sides, and then we're going to divide through. And because I'm dividing through by a positive, my inequality symbol will stay in the same direction. And now we're going to graph our solution and write the interval notation. Again, it's going to be an open parentheses at 11. We're shading to the right, and our interval notation will be parentheses 11, comma, positive infinity. So this next example has variables on opposite sides of the inequalities. So the first thing you have to do to solve for x, you're going to need to move the variables together. And whenever you move, you have to do the opposite. With inequalities, we like the variable to be on the left-hand side of the inequality symbol, so I always move to the left-hand side. So that plus 4x, I would move over to the 6x to the left-hand side, and because it's plus, I have to subtract. And once you have the variables on one side of the inequality symbol, you can solve. Now we have a two-step inequality. I'm going to subtract the 15, and then we're going to divide, and we're always thinking of that rule. Are we dividing by a negative? And we're not, so we leave the inequality symbol as is. And now I'm going to graph my solution. It's greater than or equal to, so it's going to be a bracket of 55. We're shading to the right, and the interval notation will be a bracket 55, comma, to positive infinity. Again, using parentheses at infinity. Pause and try. So we do the distributive property here. Then we combine like terms, and then you have to think of that rule. We have to divide here. We're dividing by a positive, so my inequality will stay as is. I'm going to graph the solution. It's going to be a parentheses at negative 8, and it's going to get shaded to the left. My interval notation will be from a negative infinity to negative 8, and make sure that you have parentheses because it's not including negative 8. Pause and try. Again, I'd like to move to the left-hand side. I'm subtracting that 2x over to the 5x. Now I have a two-step inequality. I'm going to add the 4, divide through. I'm thinking of that rule. I'm dividing by a positive. The inequality will stay in the same direction. It's going to be a parentheses at 4, and it's shaded to the right. My interval notation will be parentheses 4, comma, positive infinity with a parentheses. Now we have a multi-step inequality, and we're going to first have to do the distributive property here. And when you do the distributive property, be very careful with your distributing. Negative 2 times 4 is a negative 8. Negative 2 times a negative 2x is going to be a positive 4x. And then you have that negative 4 being distributed to to x, which will give us minus 4x, and negative 4 to a positive 5 will give us negative 20. Now when you combine like terms, look what happens here. When I combine like terms, my variable goes away. That plus 4x minus 4x cancels each other out, and I'm left with a negative 28 less than or equal to a negative 24. At this point, you need to make a decision. When the variables is eliminated, we lost the variable here, and the statement is true, well, negative 28 is less than negative 24. It meets the condition that it's less than. It doesn't have to meet both conditions that it's less than or equal to, just has to meet the fact that it is less than a negative 24. And because it meets that condition, any value that I put into x, I will have a true statement, so all real numbers would be the solution. The graph, again, for all real numbers would shade the entire number line, and the interval notation will be a negative infinity to infinity. So when you're given your answer, you're going to have to write it in interval notation, and the interval notation will be a negative infinity to infinity. This next example, again, we're doing the distributive property here, so I end up getting 3 minus 6x is greater than 8 minus 6x, and when I get the variables together, I'm adding 6x to both sides, you see the variable is eliminated. So the variable goes away, but when I look at my statement, it's saying that 3 is greater than 8. Well, 3 is not greater than 8, it's a false statement. So when you get the variables gone and you get a statement that's false, there will be no solution, or it's going to be the empty set, which is that symbol. So if you get the variables go away and the statement is false, there's no solution. So you would either write the empty set or you write no solution, and the graph would be a blank number line because there's no answer for it. Pause and try. So you do the distributive property, you combine like terms, and you get a statement that is true, and because the statement's true, our solution is all real numbers, the number line would be shaded in, and the interval notation is a negative infinity to infinity. Pause and try. So again, you do the distributive property. Always double check your arithmetic that you distribute properly. You're going to combine like terms, and when you move the variables together, the variables go away. You're left with 1 is less than a negative 12. False statement, no solution, and the graph is an empty number line. So now we're going to talk about compound inequalities. Compound inequalities are two inequalities connected by the word and or. So the first one I want to talk about is the and. Now, and normally is a variable between two inequality symbols. So and are all numbers between, and the variable is in the middle of the two symbols. So in this example, if I was asked, what does x equal? Well, x will be any number from a negative 3 to positive 5. It's not going to include negative 3, but it will include positive 5. So when you have an and compound inequality, it will be a variable in between two less than inequality symbols. So the next is the compound inequality or. Means that the solution must work for either inequality, a union of two inequalities. So when we talk about the union, mathematically the symbol is a union symbol, not a capital U. There's a union symbol that you need to use. So now what an example might look like of a compound inequality or would be x is less than a negative 1 or, and you'll see the word or the union symbol, x is greater than or equal to 2. So it's two separate inequalities when we have a compound inequality or. So here's an example of what an and compound inequality would look like as a graph and an interval notation. So your solution will be graphing and writing interval notation. So when we're doing a graph, again, we're going to write the graph and we're going to use the parentheses at -3 because you see the less than symbol doesn't have the equal to symbol underneath it. So it uses parentheses when it's just a less than. And then we're going to go all the way up to +5 and we use a bracket because it's less than or equal to. So you use the bracket. Now because we're talking about every value between a -3 and +5, when we graph it, we shade between the two symbols that we used to graph the numbers. So you're shading in between to indicate that all my values for x will be in between here. So the interval notation is written very similar to the graph, except for we don't have the shading part in it. So at 3, it's going to be parentheses -3, comma, 5, and then a bracket. And this is what the interval notation would look like for an and compound inequality. When we have the or compound inequality, the way that that graph would look, it would have the two inequalities graphed on the same number line, and in this case we have x is less than a -1, so you use parentheses at -1 and shade to the left, and you have x is greater than or equal to 2, so you're going to use a bracket at 2 and shade to the right, and again you're writing both of your graphs on the same number line. And then your interval notation, you'll write each interval for each inequality, and to connect the two solutions, you'll use the union symbol. So you have a -infinity, comma, -1, union with bracket 2, comma, +infinity. So this is how the interval notation would look for a compound inequality of or. So now we're going to do an example to solve, graph, and give interval notation for a compound inequality. So the first type of compound inequality that we have is an and. And when we have an and compound inequality, you want to isolate the variable in the middle of the two inequalities. And to isolate the variable, you have to undo with whatever's with it. So in this case, I have an expression of x plus 2 in the middle of the two inequality symbols. So I'm going to have to isolate the variable, and because I have a plus 2 with it, I'm going to have to do the inverse operation, which is subtract. Now be really careful here, because when you are isolating the variable in the middle, whatever you do to isolate it, you have to make sure you do to both ends of the inequality symbol. So in this case, when I isolate the x in the middle of the inequality symbols, I'm subtracting 2. I need to make sure I subtract 2 from the -2 and the +4. So my solution in this case, I will end up with a -4 is less than x, which is less than or equal to 2. So now this is my solution, and I'm going to graph the solution and write my interval notation. And remember, to graph the solution, it is going to be every number between, so you're going to shade between that -4 and 2. I'm using parentheses at -4 because it's just the less than symbol. And I'm using a bracket at 2 because it's less than or equal to. And I shade in between, and it's every number between. The interval notation looks very similar. We have a parentheses at -4, comma 2 with the bracket to include 2. So now this is a compound inequality of and, but now I have two steps to isolate the variable in the middle. So again, with a two-step inequality or two-step equation, you always undo the plus or minus first. So in this case, I'm going to get rid of that -8, so I'm going to add 8, and make sure you do it to both ends of the inequality symbol. So you have to do it to both ends. So you're going to be left with 6 is less than or equal to 3x, which is less than or equal to 18. So x is still not by itself. I have a number attached to it other than 1 Therefore, I have to get rid of it by doing the inverse operation. When a number is attached to the variable, the inverse would be division. So in this case, I'm going to have to divide by 3, and I have to divide everything by 3, both ends by 3, to get my solution. So my solution in this case would be 2 is less than or equal to x, which is less than or equal to 6. Now the variable is isolated in the middle. I can graph my solution, and we're going to have brackets at both numbers, and we're shading in between. And the interval notation will be a bracket 2, comma 6, bracket, to indicate that it includes 2 and 6, and it's every number tween. Pause and try. So you're going to subtract 3 here first, and then you're going to have to divide through by 2. And be careful here, 0 divided by 2 is simply 0. So you end up with the graph at 0 and 2 with brackets. You shade in between, and your interval notation here will be bracket 0, comma 2, bracket. So now we're going to do an OR compound inequality. An OR compound inequality are two separate inequalities connected with the word OR. So when you have two separate inequalities, you're going to solve them separately. So the first inequality is a two-step inequality. I'm going to solve. The first step is to subtract, and then I'm going to divide. And you always want to think of that rule when you divide. Am I dividing by a negative? And I'm not, so I leave the inequality as x is greater than 3. And then I'm solving the second inequality. So I'm going to first subtract the 5, and then I'm going to have to divide through by 2. And again, it's positive, so I'm not going to change the inequality symbol. And now I have my solution for this compound inequality, or x is greater than 3, or x is less than or equal to 1. So be careful when you're graphing this, because you have x is greater than 3 or x is less than or equal to 1. When you have the less than or equal to on the second position, you have to be careful with your graphing. The less than always goes on the left side of the number line. So be careful when you're graphing this. So we have at 1 we have a bracket because it's less than or equal to, and it's getting shaded to the left. And at 3 we have a parentheses because it's just greater than, and it's getting shaded to the right. And when you write your interval notation, it has to go in order of the number line. You have to have the negative infinity comma 1 first, and then you have the 3 to positive infinity second. It has to be written in the order in which you would see it on a number line. And don't forget to connect your two intervals with that union symbol. So now you see another example here of an OR. I want to solve each one of them separately. I have a two-step. I solve the inequality. I add 3, and then I'm dividing through by 2. Thinking of that rule, it's positive, so the inequality is going to stay in the same direction. The second, I solve the inequality, I'm subtracting 3, but notice in the second inequality, I have to divide through by a negative 1, which means I have to flip that inequality symbol. Because you're divided by a negative, don't forget that rule, you have to flip the inequality symbol. And now you're going to graph your solutions, and you're going to write your interval notation. So at 5 we have parentheses, it's getting shaded to the left. At 11 we have a parentheses, and it's getting shaded to the right. Make sure you're writing your interval notation in the correct order. It's going from a negative infinity to 5, and then it's going from 11 to positive infinity. And make sure you have that union symbol between your two intervals to indicate that these are the solutions for these compound inequality. Pause and try. So again, separate it into two separate inequalities and solve. And your first solution, x is less than a negative 2. Your next one is a one step, and you end up getting x is greater than 6. Graph your solutions and write your interval notation. So this is what your solution should look like in interval notation. It goes from a negative infinity to -2, that union symbol, and is going from 6 to positive infinity.